other shortcuts. So we want to know, are there other congruent shortcuts we can use when comparing two triangles? So again, here's the slide we looked at for lesson 4.4 to talk about the 6 different avenues. And today in 4.5, we are going to discuss side, angle, side, side, angle, angle, and angle, angle, angle. I believe. Let's double check. So the next slide shows us, it's angle, side, angle, not side, angle, angle. Angle, side, angle, congruence conjecture. So if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Side angle angle says if two angles in a non-included side of one triangle are congruent to two angles in a non-included side of another triangle, then the two triangles are congruent. So notice that if we have two angles that are congruent and a side, whether the included side between the two angles or a non-included side opposite one of the angles, we can conclude that the two triangles are congruent. However, if all 3 angles are congruent and that's all we know, then we cannot conclude that those two triangles are congruent. They could be just similar. So we need to know at least the measurement of one of the sides in order to determine congruency. Let's take a look at a couple of examples of how we are going to use this in our questions. So the first one we want to ask is triangle FSH congruent to triangle FSI. So when we're looking at the two triangles, we need to take a look closely at this quadrilateral. Notice that SH is 5 inches and SI is 5 inches. And it's very tempting to look at that and think, oh, that must be a square. But we can't guarantee that. We don't know the measurement of FI, and we don't know the measurement of FH, and since we don't know that all 4 angles are 90-degree angles, there's not enough information to accurately tell us that this is a square. So all we know is those two sides are 5 inches. So, SH and SI. So far, we have the side. Alright, of course FS is congruent on both triangles because it's the same, it's a shared side. So FS is working, so we have 2 sides. But notice where the angle is. So we have angle side side and angle side side. Unfortunately, as we learned from lesson 4.4, that those acronyms, angle, side, side, think about what those letters are. It's a bad word, it means it's a no-no in math, it's not happening in geometry. So unfortunately, congruency on this slide cannot be determined. We do not have enough information. If we knew the other 2 sides, then we could do side, 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 or if we knew another angle for sure, or anything else, we could probably determine that these are congruent, they look congruent, but unfortunately we don't have enough information to guarantee it. Let's look at the middle triangle. Triangle HOW, is that congruent to triangle FEW? Alright, so of course we notice that we have 2 congruent sides here, so that's good. And we notice that the vertical angles are congruent. So we have side angle, but we don't have any information about this over here, so that doesn't tell us enough. Nor do we have any information about whether those sides are parallel or not. So if these are parallel, well, I can make some determinations about this angle and this angle, but I don't know that. There's nothing to tell me that those sides are parallel. I can't make assumptions based upon just visual images. I have to be told via the markings if those are parallel or not. So unfortunately there's not enough here. All we had was side angle and then nothing else. So again, congruency on this triangle cannot be determined. Okay? Let's take a look at our third triangle. We have triangle BOX, and is that BOX, of course it's going in that direction, CAR. Well, BO is congruent to CA, so that's matching up so far. And then we have a couple of angles to work with here. We have that angle B is congruent to angle C, so those markings are matching up. And we have angle O is congruent to angle A, so those markings are matching up. So, going in the order that we want, we have angle, side, angle, telling us that those two triangles are congruent to each other. So everything matches up according to how they're labeled and with the picture. So angle, side, angle gives us the shortcut. So knowing that, we know that angle X is congruent to angle R. We know that side OX is congruent to side AR. So lots more information that we're told without actually having to do a lot of the work. Let's take a look at a couple more examples. Now, we have some information, and we want to see if we have enough information to determine the answer to the missing part. So OH, this looks very similar to that middle example on the last slide, but notice that this time it tells us that OH is parallel to AT. Right? The reason why that's important to know is because this side is a transversal, so this angle is congruent, and this angle is congruent. And then this side is a transversal, so this angle is congruent and this angle is congruent. So let's put 2 dots there. And then of course we have vertical angles here in the middle. So all 3 angles are congruent to each other, courtesy of those parallel lines. But we already know that having 3 angles congruent to each other is not enough to tell us that the triangles are congruent. What else we need to know is the measure of at least one of the sides. And so HW or WH, however you want to put it, is congruent to WT. So let's go ahead and think of how we want to name this. We know these 2 triangles are congruent, but we have to make sure we get the label correct. So WHO is the order we're going in. So WH is going to be congruent. And we want to make sure that angle H is matching up with angle T, since those are the 2 congruent angles. So then WTA. So our answer here is triangle WHO is congruent to triangle WTA. All right, let's look at the next one. Okay, we have some basic information here. We want to see what triangle RMF is congruent to. So RMF, that's this triangle right here in orange. Well, we already know that angle M is congruent to angle R. So for the second triangle, we have RMF for the first one. Angle M is in the middle, so that means R has to be in the middle here. And we know, looking at the picture, that MF is congruent to RA. So we can put RA at the end so that those letters match up. And MR is on both sides of, it's on the first triangle, MR, and it's on the second triangle as a shared side. So we know it's congruent because it's the exact same measurement. It's shared between the 2 vertices. So triangle RMF is going to be congruent to triangle MRA, courtesy of side, angle, side. So that information proves to us that these 2 triangles are congruent. So we're able to determine lots of other information about the 2 triangles. To give you in a different color what that triangle looks like, the one we just verified, MR, I want it blue. Thought I changed it, maybe didn't. There we go. There we go. So we've compared that this triangle is congruent to the orange triangle. And that's pretty much it. Between those 2 chapters, that's quite a bit of what we use with the conjectures. And of course, triangles are the building blocks of geometry, so we will be seeing these conjectures quite frequently throughout the course of our geometry unit.